Welcome to the next lecture of matrix. In today's lesson, we will discuss how to find out the inverse of a matrix using elementary transformation. We had already discussed how we can convert a matrix into identity matrix using elementary operations. We also have discussed in a separate video how we can perform the elementary operations and what are the valid and legal elementary operations on the matrix. So let us see today how we can find out the inverse of a matrix using row elementary transformation. Let's see first the concept. As we know, by the identity property of a matrix A can be written as I dot A. And as we know, if we multiply a matrix with its inverse, we get the identity matrix. So I am writing, instead of this I can write A dot A inverse. So in place of this I have written A dot A inverse. Now I am bringing this A onto the left hand side. So this will be A divided by A. This is equal to A inverse dot A. This is identity matrix. How? So this is A dot A inverse. When I'll take this A upside, this will be A dot A inverse, and this is A inverse dot A. This A dot A inverse can also be converted back to identity matrix. So this is a simple property showing that if we convert a matrix by elementary operations into the identity matrix on the left hand side, and if we perform the same operations on the right hand side, then this identity matrix will be converted to A inverse matrix. What we have to remember is we have to perform same elementary operations that we are performing on this A to convert into identity matrix. Same operations needed to be performed on this I to convert this I into the inverse of the matrix. So let's see this with an example, how we can find out the inverse of a matrix using elementary operations. So I am writing with this A. This is an example. A is a 3 by 3 matrix and I need to find out the inverse of this. Just to do so, I am also writing the identity matrix here. So this is the identity matrix with the same order. I will convert this A into identity using row elementary operations, and the same operation I'll perform into this identity matrix, and this will be converted to inverse matrix. So let me start. We already had discussed in the previous lesson that how we can convert a matrix into identity matrix using row elementary operations. I have simple 3 steps to do so. 1. First, I need to convert this into upper triangular matrix. Then I'll convert this into lower triangular matrix. And then I'll convert all the diagonal elements into the unit elements, that is 1. If you are not aware about upper triangular matrix, and if you do not know how to convert a matrix into upper triangular matrix, I also have a separate video for that. You can watch that video. If you do not know what is a lower triangular matrix and how to convert a matrix into lower triangular matrix, I also have a separate video. You can watch that video. To convert this into upper triangular matrix, first I'll target element this and element this, and I want to convert these elements into 0. So I will perform operations R2 and this R2 minus R1. This is one operation I will perform, and then the another operation for this element to become 0, I'll do R3 will be converted by R3 minus R1. Remember, for the purpose, I have to perform all the operations simultaneously on both the matrices, so that once this will convert to identity and this will convert to inverse. The first row will remain same, 1, 3 and 3. 1 minus 1, this is 0. 4 minus 3, this will be 1. 3 minus 3, this will be 0. 1 minus, and this operation 1 minus 1 will be 0. 3 minus 3, this will be 0. 4 minus 3, this will be 1. same operations, both the operations I need to perform in this. 0 minus 1, first row will be same, 1, 0, 0. Now R2 minus R1, 0 minus 1 will be a 1, 1 minus 0 will be a 1, 0 minus 0 will be a 0. Now the next operation, R3 minus R1, in this 0 minus 1 will be a 1, 0 minus 0 will be a 0, 1 minus 0 will be a 1. So these are the first two operations. So you can see the matrix have already been converted into upper triangular matrix. Now I need to convert this into lower triangular matrix. So this is already 0. I will target this element and then I'll target this element. For these two purposes, I need to perform two operations. For this element, just to convert this into 0 and then to convert this into 0. First, to convert this element into 0, I will convert R1 by R1 minus 3R3. So this is the one operation, and for this I'll perform the operation with the row number 2. So the next operation will be R1 will be converted by R1 minus 3R2. So these are the two operations I need to perform here. So let me write after performing the operation. So R1 minus 3R3. In that case, R2 will remain same, R3 will remain same. Now this is 1 minus 3R3, this will be 1. 3 minus 0, this will be 3. And then 3 minus 3R3, that is 3 minus 3 will be 0. So this is after performing this operation. And let me perform this operation on the other matrix also. So this is R1 minus 3R2. This is R1 and minus 3R3. So R1 minus 3R3, this will be plus of 3. So 1 plus 3 will be 4. Then 0 will have 0 only. Then this is R1 minus 3R3, that is 0 minus 3. So this will be minus of 3. So this is minus of 1, 1, 0, minus of 1, 0 and 1. Now I need to perform this operation, the second operation, onto these matrices. So first is R1 minus 3R2. So R1 minus 3R2, that is 1 minus, this will be 1 only. Then R1 minus 3R2, 3 minus 3, this will be 0. Now this 0 minus 3R3, this will be 0. The second row will remain same, 0, 1, 0, 0, 0, 1. And the same operation will be performed on this other matrix. So we have R1 minus 3R2, that is 4 minus 1. So this is 4 plus 3. So in that case, this will be R1 minus 3R2, 4 plus 3, this will be 7. Next is 0 minus 3. So this will be minus of 3. Next is minus 3 minus of 3R2. So this will remain minus of 3. Rest will remain same. This is minus of 1. This will be 1, 0, minus of 1, 0 and 1. So now we can see that this is converted into lower triangular matrix also. The third step, that we need to convert the diagonals into ones. Fortunately, we already have diagonals into 1, so we do not need to do anything here in this case. If we would have some other element, let's say we would have 4 here, then the R2, whole R2 would have been divided by 4. So this is already in all ones, so we do not need to do anything. So now this has been converted to identity matrix, and this identity matrix would be converted into A of inverse. So finally, A of inverse will be equal to 7 minus 3 minus 3, 1 minus 1, 0, and this is 1. This is the A inverse of the given matrix A. So this is how we can find out the inverse of a matrix using the row elementary operations. In the next lesson, we will be talking about rank of a matrix and how we calculate the rank of a matrix. Thank you so much.